All right, guys, we are going to look at lesson 7. So make sure you have that out. And once again, I'm going to show you a YouTube video, and we're going to do it this way. Let me screen share here. All right. So get your lesson out. And we'll look at lesson 7.
Lesson 7, algebraic expressions, the commutative and associative properties. Okay, so classwork 1, exercise 1. Susie draws the following picture to represent the sum of 3 plus 4. Ben looks at the picture from the opposite side of the table and says, you drew 4 plus 3. Okay, so what are they talking about here? Well, okay, so what they're saying is here is Susie drew this. And so she is basically saying that this is 3 plus 4. And if you read from left to right, it's 1, 2, 3, and then she stopped there, plus 1, 2, 3, 4. But Ben sees it as this because he's on the other side. So if he's on this side of the paper's facing him this way. Okay, now he's seeing 1, 2, 3, 4 plus 3. So why might Ben interpret this picture this way? He is reading it to right. Okay, so that's the only thing. He's looking at it from a different perspective. Exercise 2, it says Susie adds more to her picture and says, the picture now represents 3 plus 4, the original, and then I've added 2 more, so it's plus 2. How might Ben interpret this picture? So again, if he rotated this, we saw this upside down. Okay, so then if we take this and we rotate it upside down, like so, then he might interpret this as left to right, 2 plus 4. Now remember, we're talking about PEMDAS here, orders of operations, if you will. And they're parentheses, exponent, multiply, add, subtract. Well, this is addition, all addition. And when we add from left to right. So the parentheses tells us to do something first. This is just reiterating this rule from left to right if it's all addition and subtraction. So what he is seeing is 2 plus 4. So he'd be seeing this as 2 plus 4. And we have to do that first, so we put that in parentheses. And then adding 3 at the end, working from left to right. Okay, so we do want the parentheses on 2 plus 4 because we are now introducing the associative property into this and doing the parentheses first. So that's what the P stands for in PEMDAS. So here's what his interpretation might be. 2 plus 4 plus 3 working from backwards, but his parentheses are around here because we always work from left to right.
Tired of scratching YouTube for math help? TheTutorGuy.com has videos covering everything.
Exercise 3. Susie then draws another picture of squares to represent the product of 3 times 4. Ben moves to the end of the table and says, from my new seat, your picture looks like the product of 4 times 3. What picture might Susie have drawn? And why would Ben see it differently from his viewpoint? Okay, so if Susie is drawing a picture and she says it's 3 by 4 or 3 times 4, she might be looking at this. Struggling here, as you can see. All right, so let me just swing this down like this. But I want these to be squares so they're all equal, so I'm not going to do that.
Guys, make sure you're drawing this.
Let me do something else. Okay, this is better. Okay, so here is 3 times 4. Well, if Susie is looking at this, she might be here looking at it from this way. So she sees 3, and it's duplicated 4 times as it goes away from her. Okay, but Ben sees 4 times 3. So would Ben be over here, looking this way? And the answer would be no, because it would still be 3 times 4. So Ben would have to either have gone over here or over here, and looking at it from this direction, and he sees 1, 2, 3, 4 across and 3 deep. Okay. All right, exercise 4. Draw a picture to represent the quantity 3 times 4 times 5 that also could represent the quantity 4 times 5 times 3 when seen from a different viewpoint. Okay, so here is a drawing that I did. It took me a little while. It's not perfect, but you get the idea. So anyhow, it said draw a picture to represent the quantity 3 by 4. So if I was looking at it from here, then I would see 3 by 4 and a depth of 5. So actually, I would probably be looking at that from here. 3 by 4. 3 by 4 by 5. Doing the, actually it would have to be all rotated, so it would be standing up the other way. So let me see. Okay, so I've recreated this. It took a little while, but that's okay. So this would be looking at it from this side. 3 by 4, and then a depth of 5. That also could be represented in the quantity 4 by 5 by 3 when seen from a different viewpoint. So if I was looking down on it from above, no, not there, not above. Where's my 4 by 5 side for starters? So I want to do 4 by 5 first. That's this side. So if I was looking at it from this side, it'd be 4 by 5 by 3.
I'm going to pause this for just a second. Guys, it's just a matter of what angle you are looking at. All right. Notice when he's going through this, he has to reason it. His first model didn't work, so he had to restructure it. The bigger the model, the harder it is to draw. Yours may not be perfect. Mine is nowhere near perfect. Okay? But it's just a matter of making sure that you see how he is looking at it. Making sure that you see that if I were standing in front of it, this is how I would see it. If I were standing on the side of it, I would see it differently. Okay?
Okay, so just different viewpoints. So 4 properties of arithmetic are the commutative property of addition. If A and B are real numbers, then A plus B equals B plus A. Okay. The associative property of addition says that if we have A, B, and C and they're real numbers, then A plus B quantity done first plus C equals A plus quantity B plus C done first. All right, which is what we just did. The commute.
All right, let me stop for just a second here. The commutative property of addition. All right, all that's saying is if I have 5 plus 4, it is the same as 4 plus 5. Okay? You have been taught from day one that when you add, it doesn't matter what order you add your numbers in. Okay? So 5 plus 4 is the same as 4 plus 5. The associative property of addition, all it's doing here is talking about how you add your numbers in what order. All right, so let's say that I had, let me get a piece of paper here. Let's say that I have this problem. Let's say that I have 5 plus 3 in parentheses plus 2. Let's say that I am young and just learning how to add, and I'm looking at this going, is there an easier way that I can do this? The associative property tells me that I can group my numbers differently. The associative property tells me that I can move that set of parentheses and I can group that 5, or I can group the 3 and the 2 together and add those first. So instead of saying 5 plus 3 is 8 plus 2 is 10, now I'm saying 5 plus, well, 3 plus 2 is 5, so 5 plus 5 is 10. Notice it did not change the value, but the associative property allows me to see that.
Commutative property of multiplication says if A and B are real numbers, then A times B is the same as B times A. So looking at it from this way would be the same as looking at it from this way. 4 times 3 is the same as 3 times 4, just focusing on the face of that. The associative property of multiplication says if we have A, B, and C and they're all real numbers, then the quantity A times B then multiplied by C would be the same as multiplying B and C first and then multiplying by A.
Once again, the commutative property of multiplication and the associative property of multiplication are all about how you multiply your numbers. Remember, once again, when you were taught multiplication, you could multiply numbers in any order.
Okay, so exercise 5 says, viewing the diagram below from 2 different perspectives illustrates that 3 plus 4 plus 2 is equal to 2 plus 4 plus 3. Is it true for all real numbers x, y, and z that x plus y plus z should equal z plus y plus x? Note, the direct application of the associative property of addition only gives x plus y plus z equals x plus the quantity y plus z after. Parentheses moved. So can I take this and put what they did is what? Reading it right to left and left the parentheses at the beginning. So is it true for all real numbers x plus y quantity, then add z, would it be the same as z plus y plus x? Okay, so I'm going to start and I'm going to explain this by using a diagram. So if we have x plus y plus z, I'm going to put that right here. So there's my x plus y plus z. That's right here. Now, it is equivalent by the associative property that I can move the parentheses. So I'd get x plus y plus z. The other thing that changed was the parentheses, and I'm going to mark that with an A. That's the associative property. Now, if I go this way and I do the commutative property where order doesn't matter, I can put the z first. Commutative property of addition says I could say z plus the quantity x plus y without changing the parentheses. That parentheses is still around the x and the y, just that the z was added before the x plus y. And that is commutative property. Okay, so there is the associative property of the original, and there's the commutative property of the original. Okay, so now I'm going to continue doing this, and I'm going to work with this z plus x plus y, and I'm going to do the associative property of that. So what does the associative property do to that? It changes to where the parentheses are. So this would be z plus x in parentheses plus y. So the 3 letters are in the same order, but the parentheses moved. And that's the associative property. Okay, and then if I do the commutative property down here, commutative property says I can have the quantity x plus y plus z. Okay, so the only thing that changed here was the order of our 2 groups. z in the group x plus y. X plus y came first, now the z. Actually, before I get to that, let me do something else. Let me erase this. So if you copied it, I apologize, but just bear with me. That's why we have pencils in math, and that's why we erase. All right, so I want to do the commutative property over here. And that is going to be the commutative property of addition inside the parentheses. We're just going to focus on the addition for now. So that would be y plus x in here. So it's a commutative property. Order doesn't matter. We can rearrange what's in the parentheses. Okay? And then down here, I will do the associative property of addition. And that's the parentheses moving. Z plus x plus y. So the z, the x, and the y stayed the same. So I had this, but I was doing commutative property multiplication. I want to just focus on the addition here. Okay. Okay, so now if I focus on this and go over here and do an associative property on this, then the parentheses move and I get z plus y in parentheses plus x. So it's this with the parentheses move. That's the associative property. Okay, now if I come up here and do the commutative property off of this, that would be y plus z quantity plus x. And if you notice that that would also be the commutative property of this, taking this y plus z and moving the parentheses around instead of x. And our z plus y plus x is right here. So all of these are equivalent. So is it true for all real numbers x, y, and z that the quantity x plus y plus z with x and y in parentheses is equivalent to the z plus y in parentheses plus x? So we could do an associative property and then a commutative property and then another commutative property, or we could have done the commutative property twice and then the associative property. And that shows that all of these are equivalent. So is it true? The answer is yes. Now, if we did this as a proof, and I take the original, here's what it would look like. I would take the quantity x plus y plus z, my original right here. And I'm going to say that that equals, and I can follow any path. I'll go this way. So that'd be z plus quantity x plus y. Okay, and that's the commutative property. And then that would equal z plus y plus x, which is also the commutative property. And then finally, move the parentheses, and that is the associative. And there's our proof in 3 steps.
Braxton was diagnosed with choroid plexus carcinoma, a brain tumor.
Exercise 6, draw a flow diagram and use it to prove that x times y times z equals z times y times x for all real numbers x, y, and z. So pause the video, see if you can do that, and then come back and check. Okay, so I'm going to start the diagram like so, and I'm going to do the associative property on this, which would be x, y, z, the letters in the same order, just the parentheses moving. And the commutative property says that order doesn't matter, so I can put the z first and then the x, y second. So there's the start of the flow diagram for this, and we want to get to zy times x. Okay, so from this one, what can we do? Well, I can do this, and I can rearrange the z and the y in the parentheses, and that is a commutative property. Order does not matter. And then when I continue, then I can take the z and the y and put them before the x, and that is also a commutative property. And now we have zyx. Now going this way, we have zxy, okay? And then I can rewrite that as zyx, and that's the commutative property of multiplication, where the y and the x just switched orders. Okay, and then from that, I can move my parentheses to zyx, and that's the associative property. And there we have it, zyx. So actually, I can erase this, move this down here. Let's do this. We got to the same point, we're done. And I will just redraw this, and that is commutative property. And this is associative. Okay, so there's our outcome.
Guys, when you're drawing the flow diagram, you do not have to do both branches. He is just showing you that you can start with the associative property, or you can start with a commutative property. It is your choice which one you want to do. Most of them you're going to see are going to be ones that are going to do both branches, but know that if I ask you to do a flow chart or a flow diagram, that you can, all you have to do is you can do the top part. You can start with the associative and finish it out that way. Or you could do the start with the commutative and finish it out that way.
So if I wanted to write this as a proof, I can go in either direction. So I can say x, y, z equals this, z, x, y. And that is just moving that over here. That's the commutative property. And that's going to equal, over here, my pen's acting wacky, it's bouncing around. Now it's zyx, z, y, x. Okay, all I did is rearrange what's in the parentheses. That's also the commutative property. And then move the parentheses, so it's z, y, and x out here, and that's the associative property. Okay, exercise 7 says, use these abbreviations for the properties of real numbers and complete the flow diagram. C with a plus for commutative property addition, C with an X commutative property multiplication, A sub plus and A sub X. Okay, so X plus 4 plus 5 times A plus 2XY, and then we look over here and what happened? Well, this 5 and all this moved out in front, and the X plus 4 moved out back here, so that's the commutative property of addition. We rearranged addition. Order of addition did not change. So now we have 5A, 2XY, 5A, Y, 2X. So this got rearranged, this piece here. Let me change colors. So what changed from here was this to this. That's the key. The A stayed the same, the X plus 4 stayed the same. We rearranged multiplication. So that's C, multiplication. Okay, so now let me erase this. Now I want to focus on what changed here. I have a 5 still there. A plus 2XY, A plus 2XY stayed there, plus stayed there, plus stayed there. X plus 4, X plus 4. Here's what's changed. Let me change colors. So what changed this time was this 2xy. And what moved was the parentheses. 2x was in parentheses here, and the 2 is now no longer in parentheses, the xy is. So that's the associative property of multiplication. Okay, you get the idea now? Now we have x plus 4, 5a, 2xy. 5a, 2xy didn't change. The x plus 4 became 4 plus x. That's order doesn't matter in addition. So that's the commutative property of addition. Okay, let's change colors again. What's changed from here to here is, let me erase this circle. We have the y, we have the 2x, we have a, we have x. So 4 plus x plus 5, 4 plus x plus 5, a plus 2xy, a plus 2xy. Everything's in the same exact order, so that guarantees the associative property, because the only thing that's changed is the parentheses. And it went from the 4 plus x to
Smana is like very outgoing.
here. It went to here. So this one's gone and it moved to here. And that's the only thing that changed. We moved the parentheses. So that's the associative property of addition. So we're going to do everything inside here and then add 4 after. Before we were adding these. Okay. Now this one, 4 is not in the same place, so I know something's been rearranged, so I know it's the commutative property. So it's a commutative property of what? It was 4 plus this, now it's this plus 4. So that rearranged addition, so it's commutative property of addition. Okay. Moving on, exercise 8. It says let A, B, C, and D be real numbers. Fill in the missing term of the following diagram to show that the quantity A plus B plus C, all done before adding D, is sure to equal A plus the quantity B plus another quantity C plus D. So A, B, C, D, A, B, C, D. The orders didn't change, so it's not commutative. The parentheses changed, it's associative. So we have an associative property here. We move this parentheses from here to here. That's what happened on that step. And then from this step to this step, what's going to happen? And then to eventually get to here. So I would probably move this parentheses to here. Thus giving us A plus B plus C, that's a B. Okay, so there were 2 parentheses here, but I'm going to put a plus D here and put the parentheses out here. So I need another parentheses. Actually, that's not what happened. Let me erase that. I'm going to keep the B plus C in parentheses. I can't right now. Parentheses, B plus C. That's going to stay in parentheses. I'm going to move this parentheses to here and this parentheses to here. Okay, so this is going here and this one's going here. So it's going to be A plus this quantity plus D. Okay, so I had to get the A out of the parentheses. So I moved the big parentheses over one. So now the A is outside. And then this group here is inside with this D, and then I move the grouping over one more time. So there is the proper adjustment.
All right, I'm gonna stop him. Make sure that you are reading through your vocabulary. The bottom page here has a lot of vocabulary that's very important. Make sure you're reading through that and make sure you're understanding it. All right? All right, guys, this is the end of the lesson.